close one, guys. Okay, 6, 5, 6, 6. Graphically, we already talked about that. Area between the curve and the axis over A to B. Number 2, solved with geometry if it fits a geometric formula, like triangles and rectangles and half circles. Oh my. Number 3, approximated. How? Using, we already talked about it, rectangles. Rectangles have what as their area formula from our forever card? A equals base times height. Base, change in x, height, f of x value. Then we also had trapezoids. By the way, do you have lots of things to be memorizing in your forever cards?
Oh, yeah.
Tons of integration formulas, Riemann sum approximations, etc., etc. Definition of an integral. A equals 1/2 base times height 1 plus height 2. Ay, ay, ay. There we go. Algebraically, that is the question. Whether 'tis noble or just kidding. Here we go, number 4. Okay, so algebraically. To solve by hand or to not solve by hand? Okay, here we go. Properties, you already wrote them down, right?
Right.
From A to A, we already talked about it. You're not going anywhere, so you're not covering any area, so then of course it would be 0. B to A, that's backwards. And if we're going backwards, there's going to be a negative displacement. That's all I'm going to say for right now. But it's going to be negative going forwards. Okay? Going backwards, what do I mean by backwards? From a higher to a lower. Because we always go from a lower to a higher because we're talking about an interval. But if they have the bound switch, I can still do it. It's just going to be negative of the normal. We already saw I can pull a constant out of an indefinite, so of course we could do it from a definite. If I am, now this is going to be important, especially when we get to absolute value, you can take an interval from one to another, and I can say, you know what? Even though that's all well and good, I can also go from one to an in-between, and then an in-between to the other. Actually, it doesn't have to be in-between. Because even if C was beyond B, then if I went from C to B, it would be negative B to C, so I would take away the extra area. Anyway, it's getting a little crazy. We'll just stop there. And then last but not least, because we saw it with indefinite integrals and Riemann sums before that and limits as well, we can say integral of f plus or minus g, we can split it up with definite, just like we could with indefinite. And that brings us to the following example. Can I scroll down? Please say yes.
Yeah.
And if you didn't mean it, I didn't want you to lie. Okay, so bookwork for section 6.5 to 6.6. People who have looked online already hopefully haven't printed it out already. You just have to make sure you match up the next homework with the right sections because it's out of order online. I'll fix it during lunch. Here we go. If I want to find the integral from 1 to 4 of 3f of x minus g of x, amazing ones, what would I do? If they told me 1 to 4 is 2 and 1 to 4 of g is 10. Plug it in using all of my nifty formulas to prove that I really can. But can I really say that 3 times f of x integrated is the same thing as 3 times the integral of f of x over the same bounds? Yes. 3 times 2 minus 10. Booyah, that was easy, negative 4. We're just seeing if you understand the book and I. It's kind of scary that we're we. Anyway. You can use your properties. Negative 4. Make sense? Moving on. Can I?
Yes.
Hold on. Yeah? Okay.
Oh no.
We can't solve it algebraically until we look at this. And I don't prove much in this class, and college professors would hate me because I don't, because they would be like the pure mathematicians that are like, if you don't understand the law, then you can't possibly apply. Anyway. But this one I do like to prove. And we have 2 minutes. Sadly, I don't think we'll get to prove it today, but you will have it hopefully all written down so that we can come in tomorrow. You'll have the hard part done, and then you'll get to see the amazingness of the fundamental theorem of calculus. that allows us to take the idea of area between two bounds and take the idea of an antiderivative being the function that you solve. And by looking back to mean value theorem, peek at it tonight, mean value theorem, we can resolve the two and figure out how to solve any definite integral given that we can find the antiderivative. There we go. So we're going to end class by you guys writing down the set up to the proof for the fundamental theorem of calculus. Sounds pretty spiffy, huh? There was a fundamental theorem of algebra once upon a time, but this one's way more exciting. Because we basically see infinite math brought down to one subtraction. Of course, remember I said we wouldn't have to solve integrals by their definition, the limit of the Riemann sums. If we did, we would need different math. But we can see by the fundamental theorem of calculus how we can use antiderivatives in order to solve for a finite area. And a whole new world opens up. Cool kids, congratulations, group number 5. The rest of you guys, homework is not due until Friday. We can probably start tonight because it starts with properties. Remember, you're doing 6566. Remember, you're doing section 6566 homework. I'll rearrange it right now so it comes next. You're working on AP 10 if you haven't started yet. We're not doing so good on this one. We did better on AP 9. I see some of you working. I see a lot of you forgetting. So let's stop the forgetting and let's start the working. My guys who are behind on any homework, catch up now. It'll be way easier than later. See ya. You can keep writing. You're amazing. We finished. You may go. Bye, guys.
What are you doing?
Sorry, I'm bringing it down. I thought that would be it.
No, but see, you have to put the big day in too.
Not the official today, but I'll pop it in. Layla was going over 5 minutes during class, hopefully. See if we can get in there early. I don't think we're gonna find it. If I were you though, Richmond might seem to. Huh? Make the popcorn taste better since we probably didn't get it. We might
No, Layla said she was gonna do it. She said in the group chat.
get butter salt or whatever.
Oh,
Just be salt.
no. It worked. It was planned, but I thought maybe. Yeah, I mean, not.
Or just salt. Did she say she was gonna get
We
it?
should go with this. No, she said she was gonna set the popcorn machine. She has a meeting.
If someone is bold enough to go ask Richmond, it might let you borrow it. He has it, I've seen him use
The
it.
popcorn machine?
The salt.
Oh, no, the salt. That, yeah.
Unless, I mean, you can still
Caleb
be.
bought the straight up butter and put it on there. I don't know how that tasted.
It would be an adventure. I don't know. Yeah, adventure.
What are you doing? I think that one of them we either differentiated or disputed. They decide how they
We never differentiated things, but we might have, there was a funny one. Was it the 10 to the x, L, and 10?
that one too. That one had the.
That one was a rule that we technically haven't seen. But it is a derivative that we learned, so I was just seeing if anybody can see that it's a derivative. So that one, go ahead and wait on, don't stress about that. Whenever you had E, remember E is its own derivative, so it's not that I derived it to get equinox, it's that I integrated that E is the derivative. If you want, here, let me stop the recording. Because then people write it down.